Hi everyone. Good evening, good evening, good evening. Hi everyone. Hi. So now I am live and we will discuss in this live session uh, about unit and measurement. In this live session we are going to discuss and learn about the unit and measurement. So please join fast everybody. Only one Maya Gloria has joined me till now. Join all viewers, listeners. So, unit and measurement is a very important chapter. So, in this video, we will discuss and learn about it. So, let's start. So, unit and measurement. What is unit and what is a measurement? We will discuss first the measurement. What is measurement? Measurement, the comparison of any physical quantities with the standard unit is called the measurement. So what is measurement means comparison between the physical quantities as well as the standard unit that is known as a measurement. Physical quantities, if you'll see here, then it is written physical quantity. So the question will arise in our minds, what is physical quantities? So all the quantities which can be measured directly or indirectly, that is known as a physical quantity according to the law of physics, that is known as a physical quantities are which we can measure the directly or indirectly. So next, which we have the unit, which we have seen in the topics, the title of chapter, units and measurement. So in that we have seen the units. So unit is a standard amount of physical quantity. Unit is nothing but it is a standard amount of a physical quantities chosen by chosen to the measure physical quantity of the same kinds is called the physical unit. So why we are using the units to measure the physical quantities, and that quantities in a same kinds, that is known as a physical unit. It should be easily reproducible and internationally accepted. Before the units, we were using the system. So we have some system earlier. We have some system, and that system name was FPS system, CGS system, MKS system. Like that system, it was earlier, but now we accepted the units, and which that standard units we have accepted in international level. So if you nowadays, if you want to measure any physical quantities, then we required SI unit. We required to measure the any kinds of physical quantities which comes under the standard amount of physical quantity. So that physical quantity we can measure with the help of SI unit, and this unit acceptable internationally. If we want to measure 1 kg rice in India, then we are able and we are feeling convenience to measure 1 kg rice in Dubai. So we have accepted the internationally the SI unit system. Now then we have the fundamental quantities. What is the fundamental quantities? The fundamental quantity is known as the base quantities also, are standard quantities. Those quantities which independent to each other are called fundamental quantities. So these kinds of quantities never depend to the other physical quantities. Other physical quantities, that is known as a independent or fundamental quantities or independent quantities, we can say. So fundamental quantities, we have 7 fundamental quantities, or we can say we have a 7 base quantities which we can measure the which we can use to measure the physical quantities. According to the fundamental, we have some derived quantities. When derived quantities means which quantities depend to the other quantities, that is known as a derived quantity. I hope you are getting this concept. Now we have a 7 fundamental quantities, and now we are going to discuss each and every fundamental quantities. So first we have length. Length is a fundamental quantities or base quantities. The name meter, we are measuring the length in a meter, and symbol of length is a symbol of length which we are measuring in meter. We are we are denoting with the small letter m. And definition of the length is the meter is the length of the path traveled by in the light in vacuum during the time interval of 1 upon 299 millions 458 of a second in years of 1983. So during the 1983, we got the definition of the length by our famous scientist, and there is one committee. That committee has decided we have to accept and we have to implement the length we will measure in the meter. Anywhere we can, hereafter we can measure the length in a meter. Yes or not? Good evening, good evening. So next we have fundamental quantities. Next fundamental quantities which we have, the second fundamental quantities which we have, the mass. Mass we are measuring in a kilogram, and the symbol of mass is a kg. What is the symbol of mass? The symbol of mass is kg. So mass definition is the kilogram is equal to the mass of the international prototype of the kilogram. Prototype of the kilogram is at the time when they are defining the mass, then they have taken the platinum, iridium alloy, and they kept in the cylinder. According to that, they have defined the mass, and where they have kept, they kept at the International Bureau of Weight and Measure of the survey. At a survey, during a survey, they kept the platinum, iridium alloy in a cylinder, where that place is International Bureau of Weights and Measures at a survey near Paris in France during the 1889. During the 1889. Now next next fundamental which we have, the time. So time fundamental is time is a fundamental quantities, and then SI unit of the time is second, and symbol of second SI unit is S. We are representing the time with a small letter s. And definition of the time is the second is the duration of 9,192,631,770 periods of a radiation corresponding to the transition between two hyperfine level of the ground state of a cadmium 133 atoms during the 1967. During the 1967, they have defined that committee has defined the time definition. They have given the time definition according to the radiation corresponding to the transmission between the hyperfine level into the level of the ground state of the cadmium. The atom number is 133. Next fundamental we have electric current. So electric current we are measuring as a ampere, and SI unit of electric current is a. So the SI unit of current is a ampere, and we are measuring the current in a ampere, and we are denoting ampere as a capital letter A. Here the definition of ampere is, the ampere is that constant current which, if maintained it to strength parallel conductor of infinite length of an axial circular cross section and placed 1 meter apart in a vacuum, would produce a force between this conductor equal to 2 into 10 to the power 10 inverse 7 Newton meter of length during the 1948. So during the 1948 they have defined the electric current, and the electric current SI unit is ampere, and we are denoting the electric current as a capital letter A, and they have defined the parallel conductor of the infinite length of a negligible. Suppose this is a conductor and this is also a conductor, so both are parallel to each other. These both are parallel to each other. If you now you will see, then this is a parallel, but here it is joined, so we cannot, this is a parallel, but from here if I will remove, then you can see this is a parallel. So the parallel conductor of an infinite length, the length is not fixed, that length is infinite. So between the infinite length of the negligible circular cross section, so this is a, suppose it is a conductor and this is a cross section of the conductor, so and place 1 meter apart in a vacuum, then that time the conductor equal to the 10 to the power 2 into 10 to the 10 inverse 7 Newton meter of length during the 1948. Next fundamental units we have, fundamental quantity which we have thermodynamics, Kelvin, or thermodynamics we can say temperature, because thermodynamics is a subject. In that subject we are studying about the temperature. We are studying about the temperature. Thermodynamics books is like this. So thermodynamics book, and in that we have to study about the temperature. So temperature we are measuring in the Kelvin, and a SI unit of temperature is Kelvin, and we are denoting the temperature with letter K capital. And definition of the temperature they have find during the 1967. The Kelvin is the fraction 1 upon 273.16 of the thermodynamics temperature of the triple point of water. So how they have defined the temperature? They have defined the temperature through the thermodynamics, and the thermodynamics they have got the temperature of the triple point of water during the 1967, and we are measuring the temperature as a Kelvin. We know that the temperature SI unit is a Kelvin. We are measuring the degree Celsius and Fahrenheit, but the SI unit of temperature is Kelvin, and we are denoting the temperature with a capital letter K. Now next which we have, the next fundamental unit which we have, the amount of substance. Amount of substance we are measuring in a mole, and the SI unit of this is the SI unit of the amount of substance, and we are denoting the amount of substance. We are writing capital small MOL. So mole we are writing, and the definition of mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon 12. According to the carbon 12, they have defined the amount of substance during the 1971. Now next, the last fundamental units which we have, the luminous intensity, and the luminous intensity SI unit is the candela. We are writing, we are denoting the luminous intensity, a small letter CD. The definition of the candela is, the luminous intensity is in a given direction of a source that emits monochromatic radiation of the frequency 540 into 10 to the power 12 hertz, and that has a radiant intensity in that direction of 1 upon 683 watt per steradian during the 1979. During the 1979, they have defined about the luminous intensity. The luminous intensity they have defined according to the source of light. When we are providing the source of light, then the light have photons, and every photons emits. While they are emitting which kinds of light, they have taken the monochromatic light. So monochromatic light means what? Only white, one color. Mono means one, and chromatic means color. So one color light radiation they have taken, and that monochromatic light radiation of a frequency at the time 540 into 10 to the power 12 hertz. As we know that we have a frequency in our country, have a frequency. What is the frequency hertz in hertz? 50 hertz of our India country frequency, yes or not? At that has a radiation intensity in the direction of the 1 upon 683 watt per steradian during the 1979. Next, we have a supplementary units. Before the supplementary units, we have a fundamental units. We have a derived unit, and derived unit based on the fundamental units, and we can define the derived unit. Derived unit is depend on the fundamental units. Derived unit made by the fundamental units. Suppose we want to find the area of any surface. So if we want to find the notebook area, then we are writing meter square. So meter square is the area SI unit, yes or not? So what we are doing, actually we are doing the multiplication between length, yes or not? And length we are measuring in a meter, yes or not? So in the derived unit is based on the fundamental units, and there are all kinds of derived units like a force is a derived unit, velocity is also derived unit. So these all are the derived unit, and these all are the depend on the base unit. Base unit means fundamental units or fundamental quantities, yes or not? Next, we have a supplementary units. Supplementary units are, we can say, supplementary fundamental quantities and their units. Now we are going to discuss about the supplementary units are supplementary fundamental units and their SI units. So we have two types of supplementary units. One is a plane angle, another is a solid angle. So radian and steradian are two supplementary fundamental units. It measure plane angle as well as a solid angle respectively. So first one, plane angle. Plane angle SI unit is a radian, and symbol is a small rad. And definition of the plane angle: 1 radian is the angle subtended at the center of a circle by an arc equal in a length to the radius of the circle, that is d theta upon ds, d theta equal to ds upon r. Here change in angle equal to change in displacement upon radius. Now next, which we have solid angle. Solid angle we are measuring, the SI unit is a steradian, and we are measuring solid angle in the steradian, and symbol of solid angle is SR, small SR, and we can define the solid angle change in ohm. Change in resistance equal to change in area upon distance square between them. Radius of square of radius. Square of radius. 1 steradian is a solid angle subtend at the center of a sphere by that surface of the sphere which is equal in area, which is equal in area to a square of the radius of a sphere. That is change. D is a, we are writing D as a change, yes or not, or differentiation. So D ohm equal to D upon A upon D ohm equal to D upon D A upon R square. So here change in area upon R square. Now next we have derived quantities and their units. So those physical quantities which are derived from the fundamental or base. Now I said na, derived quantities means those quantities depend on the base units are fundamental quantities. So we already, I told you about the fundamental quantities. Now you tell me how many fundamental quantities we have. So we have 7 fundamental quantities. Yes or not? What are they? Length, time, mass, temperature, amount of substance. These all are the luminous intensity, electric current. These all are the what? These all are the fundamental units, or we can say fundamental quantity. Now derived quantities and their SI unit. Those physical quantities which are derived from fundamental, which are already derived means which are origin from by the fundamental units through the fundamental units, that is known as the derived quantities. For example, we can say velocity is a derived quantities or derived unit, because we know that the velocity formula displacement upon time, yes or not. So change in displacement, so displacement upon time. So here we can see the displacement SI unit, we are measuring the displacement in a meter, and time you are measuring in a second. So here velocity SI unit is a meter per second. Acceleration, what is the acceleration? Change in velocity upon time. So final velocity minus initial velocity upon time. So here v minus u upon t. So here SI unit of velocity we are taking meter per second, and time SI unit is a second. So second will multiple together. So the SI unit of acceleration is a meter per second square. Force, what is the force? Force formula mass into acceleration. Force is equal to mass into acceleration. So force SI unit is a Newton we are writing also, or we are writing kg meter per second square. Work also, yes or not? So these all are the SI unit of the derived quantities. Next, system of units. So earlier, before accepting the SI unit, we were using the systems, CGS system, FPS system, MKS system. So now we will discuss about the system of units. A system of unit is the complete set of unit. What is the system of unit? It is a set, and in that the complete set of unit we will get both fundamental and derived from all kinds of physical quantities. From all kinds of physical quantities. Whatever the physical quantities are here, which are present in the world, all physical quantities, and as well as the derived as well as the fundamental, all physical quantities, the common system of a unit which is used in a machine are given below. Mechanics are given below. First is system, CGS system. CGS system is, what is the full form of CGS system? In this system, the unit of length is in a centimeter, the unit of mass is kilogram, and the unit of time is second. FPS, second is the FPS system. FPS system full form is, in this system the unit of length is foot, the unit of mass is pound, and the unit of time is second. Next, third one, MKS system. In this system, the unit of length is meter, and the unit of mass is kilogram, and then unit of time is second. And fourth one, SI system. The system of unit which is accepted internationally for measurement is the system international units, abbreviated as SI. This system contains 7 fundamental units and 2 supplementary units. So SI system, nowadays we are using SI units or SI system you are using, and in this SI system 2 quantities are there. One is the fundamental quantities, another is supplementary quantities. Now relation between some mechanical SI unit and then commonly used units we will discuss. Now we are going to discuss about the relation between SI unit as well as the common use units. So length, first physical quantity is a length. So 1 micrometer equal to 10 inverse 6 meter. 1 micrometer equal to 10 inverse 6 meter, and 1 nanometer equal to 10 inverse 9 meter, and 1 angstrom equal to 10 inverse 10 meter. 1 angstrom equal to 10 inverse 10 meter. Now next one, mass. Mass, 1 metric ton equal to 10 to the power 3 kg. 1 pound equal to 0.4537 kg. 1 mu equal to 1 AMU means atomic mass of unit. So 1 atomic mass of unit equal to 1.66 into 10 to the 10 inverse 23 kilogram. Volume, 1 liter equal to 10 inverse 3 meter cube. Force, 1 Dyn equal to 10 inverse 5 Newton, or we can write 1 kgf equal to 9.81 Newton. Next one, pressure. Fifth one, pressure. Pressure 1 kgf meter square equal to 9.81 Newton meter inverse 2, or we can say Newton per meter square. 1 mm of Hg equal to 1 mm of Hg. Hg means mercury equal to 133 Newton per meter square or Newton meter inverse square. 1 Pascal equal to 1 Newton per meter square. 1 atmospheric pressure equal to 76 centimeter of Hg equal to, Hg means what? Mercury, equal to 1.01 into 10 to the power 5 Pascal. So next one, physical quantities, work and energy. Work and energy. So here first unit, 1 arg. 1 arg equal to 10 inverse 7 joule, and 1 kgf meter equal to 9.81 joule, and 1 kilowatt hour equal to 3.6 into 10 to the power 6 joule, and 1 electron volt equal to 1.6 into 10 to the 10 inverse 19 joule. 10 inverse 19 joule. Next, which we have power. Power, 1 kgf meter per second equal to 9.81 watt, and another one, 1 horsepower equal to 746 watt. So these all are about the relationship between some mechanical SI unit as well as the common SI unit. Now next we are going to discuss some practical unit of length. Some practical unit of length. So 1 Fermi equal to 10 inverse 15 meter. 1 X-ray unit equal to 10 inverse 13 meter. 1 astronomical unit equal to 1.49 into 10 inverse 11 meter. Average distance between Sun and Earth. How we are taking? we are using the astronomical unit. Astronomical unit is a big SI unit for measure the length between earth and sun. Between earth and sun. Suppose if you want to measure the length from here to Patna, so we cannot use the astronomical unit, but if you want to measure the distance from here to moon or here to sun, then we are using the SI unit of length is angstrom unit. So that's why the angstrom unit equal to 1 angstrom unit equal to 1.49 into 10 inverse 11. Next, which we have 1 light years equal to 9.4 into 10 to the power 15 meter. 1 parsec equal to 3.08 into 10 inverse 16 meter equal to 3.26 light year. 3.26 light year. Now next, which we have dimension. Now, so derived quantities, we know that two types of quantities. One is a scalar, another is a physical vector quantities. A scalar and vector quantities. So a scalar have a magnitude, but the vector have a magnitude as well as a direction. So direction. But now we are going to discuss about the dimension. Dimension of any physical quantities are those power to which the fundamental quantities are raised to express that quantities. The expression of a physical quantities in terms of its dimension is called a dimensional formula. Or we can MLT function, we can say MLT function. MLT function means M stand for mass, L stand for length, and T stand for time. So dimensional formula we are using to exponent, we are using to express the SI unit in a exponent raising to the power of SI unit and expressing that quantities, the expression of physical quantity in the terms of dimension, that is called dimensional formula. So dimensional formula of some physical quantity now we will discuss. We have, so first dimensional formula of physical quantities, we have area. Area, how, what is the formula? Area, length into breadth, yes or not? So we are measuring L into B, so L also we are measuring in M, and breadth also we are measuring in a M, in meter. So meter into meter, it will becomes meter square MKS system, MKS unit, yes or not? Nowadays we are using two systems, one is the MKS, another is SI unit system, yes or not? SI unit system, international standard units we are using. So this is the MKS units, and this is the dimensional formula. So what is the area dimensional formula? L square. Here we are not writing M because length we are measuring in a meter. So that's why for writing the dimensional formula of area, we will use, in the place of M we will use capital L. So 2 times M is written. So here we will write 2 times and it is a square of L. Now next one, volume. Volume you are measuring into length into breadth into height. So L into L into L, or meter into meter square. Meter into meter, it will becomes meter cube. So that's why we will write the dimensional formula of a volume is LQ. Dimensional formula for volume is LQ. Next we have velocity. Velocity, what is the velocity formula? Change into displacement upon time. Upon time. So displacement means what? Length, yes or not? So length we are measuring in a meter. So meter, for meter we will write L, and upon time. So if we will take the time this into the multiplication to the L, then the time becomes inverse. So that's why the dimensional formula for velocity is a MLT inverse 1, and the SI unit of velocity is meter second inverse or meter per second, we can say. Now next, fourth one, acceleration. What is the acceleration formula? Acceleration SI unit is a meter per second square. Meter per second square. And then we can write the MLT function, MLT formula of the, or we can write the dimensional formula for the acceleration is L into T inverse 2. LT inverse 2. Because mass is 0 here. Mass is not given. If you will write the MLT function, means you must have to write M not L1 and T inverse 2. Yes or not? Here point exponent digit is not written here. Suppose if you want to write in the MLT function, so in the view of MLT function, then M exponent is 0 and L exponent is 1 and T inverse 2. We will write like this. So dimensional formula, you can use this one or you can use that one. No problem in that. Next, force. So force SI unit is a Newton meter. But what is the formula? Force formula is mass into acceleration. So we know that the acceleration dimensional formula. What is the acceleration dimensional formula? Please write in the chat box. Please write in the chat box what is the acceleration MLT formula or dimensional formula. Yes. So acceleration dimensional formula is LT inverse 2. LT inverse 2. So mass, force formula mass into acceleration. Mass we are measuring in a kg. Yes or not? So kg, for kg we are writing capital M. So M into L into T inverse 2. T inverse 2. Here M exponent is 1 and L exponent is 1 also, and T exponent is minus 2 because T is divided by L. T is divided by L. Yes or not? What is the formula of acceleration? Change into velocity upon time. Yes or not? So velocity SI unit is what? Meter per second, and time SI unit is what? Second. So this second will goes up, then it will becomes a multiplication with the S. So S becomes a square of it. Yes or not? Now next one which we have, work and energy. Work or energy, both dimensional formula is similar. So here work displacement, work and energy work and energy dimensional formula is M into L square into T inverse 2. The SI unit of work and energy is joule. We can measure the work in the joule also, and energy also we are measuring in joule. Now next which we have, the next power. So power dimensional formula M into L square T inverse 2, and it is also measured in joule inverse second. Joule second inverse or watt. Next, pressure or stress. So pressure or stress we are measuring in MLT inverse 1 into T inverse 2, and SI unit of this is Newton per meter square. Now next one, linear momentum or impulse. Linear momentum formula, what is? P equal to mb. What is the pressure formula? Force upon area. Force upon area. Yes or not? Now linear momentum SI unit, linear momentum formula is mb. So here the dimensional formula for the linear momentum or impulse equal to ml T inverse 1, and the SI unit is a kg meter per second. Now next one, density SI unit is a m into LQ inverse, m into L inverse 3, and meter Q. SI unit is a kg per meter Q. Kg per meter Q. Stress does not have any dimension, does not have any SI unit, so that's why it is a dimensionless. Now here we have to understand one thing, dear viewers. Those physical quantities does not have any kinds of SI unit, then that quantity is known as a dimensionless. Those quantities have a units which we can use to measure. So that quantities have a count as a dimension. That quantities have a dimension, but those quantities does not have any kinds of SI unit to measure it. Then we can say that is a dimensionless. Here a stress. Suppose you are taking a stress for your preparation of exam or anything. So there is no any that a stress means what? A stress is a feelings, yes or not? So a stress is a dimensionless because it is a unitless physical quantities. Now next one, next physical quantities which we have, modules of elasticity, modules of elasticity. So dimensional formula of modules of elasticity, ml inverse 1 into t inverse 2. The SI unit is a Newton per meter square, and surface tension, stress upon strain, the formula of surface tension. So the formula, dimensional formula for the surface tension is m into t inverse 2, and SI unit is a Newton meter inverse 1. Now next one, velocity gradient. So velocity gradient dimensional formula is t inverse 1, m naught, l naught, and t inverse 1. The SI unit is a second inverse. Coefficient of viscosity, ml inverse 1, t inverse 1, and SI unit of coefficient of viscosity. Viscosity means suppose we have a liquid. So how we can measure the thickness of the liquid? That liquid we are measuring coefficient of viscosity. Viscosity means in Hindi we can say how much chipchipa. In Hindi we can say chipchipa means how much it have a denser. So we are measuring in a coefficient of viscosity, kilogram meter inverse second inverse. Gravitational constant. What is the gravitational constant? Gravitational constant m inverse 1, l q, t inverse 2, because SI unit of gravitational constant is Newton meter square per kg square. Newton meter square per kg square. What is the formula of gravitational force? F equal to g into m1 m2 upon r square. Yes or not? So if you want to find the g, then r square becomes a multiplication with the f. So f SI unit is a Newton, and r square, r is nothing but it is a distance between mass 1 and mass 2. Yes or not? Mass 1 and mass 2. So we are writing L square, so meter square here, and mass 1 and mass 2 is we are measuring in a kg, so kilogram square. Now next which we have, angular velocity, moment of inertia. What is the moment of inertia? Moment of inertia inertia is the law of motion. Yes or not? First law of motion which is given by the Newton's Sir Isaac Newton. Sir Newton has given first law of motion. What is the first law of motion? When an object is in a rest, it will remain at a rest while we are not, until we are not applying any external force over the body. Yes or not? And that motion, first law of motion, also known as the law of inertia. But here is the moment of inertia. So moment of inertia dimension formula is ml inverse ml square, and t exponent is not here because time is not here, and SI unit of moment of inertia is kilogram meter square. Now next which we have, the next angular velocity. Angular velocity we have t inverse 1. T inverse 1 we have. Next, then angular velocity radian per second. Angular acceleration t inverse 2 radian per second square. Angular momentum meter. This m stand for what? Not this m stand for mass. Mass into L. So length measure in a meter square. So meter square and t inverse 1. And SI unit of angular momentum is kilogram meter square per second. Now next one, a specific heat, L square T inverse 2 and theta minus 1. So kilocalories kg inverse Kelvin. Latent heat, L square into T inverse 2 and kilocalories per kg. Planck constant, M into L square into T inverse 1 joule per second, joule second. Universal gas constant, M into L square into T inverse 2 theta inverse 1. SI unit is a joule per mole Kelvin. So these all are we have, which we have now we have discussed and learned about the what, dimensional formula. Next we are going to discuss the homogeneity principle. Now we are going to discuss the homogeneity principle. Now homogeneity principle. So homogeneity principle, if the dimension of left hand side of an equation are equal to the dimension of right hand side of the equation, then the equation is dimensionally correct. This is known as the homogeneity principle mathematically. LHS equal to RHS. So uh, homogeneity means RHS is equal to LHS or LHS is equal to RHS. Suppose we have equation, suppose F equal to M into A. So how we are getting N from the M into A? From the RHS we are getting N. So from the F we will get N. So these will satisfy the homogeneity principle. If both LHS and RHS will comes different, we will get the different values for the equation, then we cannot, then that equation will not satisfy the homogeneity principle. Homogeneity principle means we have a two equation, we have a equation and that equation have before the equal and after the equal. It means the in the LHS and the RHS both values are similar to each other, then that equation will satisfy the homogeneity principle. So that's all for today. We will discuss tomorrow live session remains topics which we have in this chapter. Then the remains topics which we have in this chapter I am telling. Application of dimension, I will give some example homogeneity principle tomorrow. So don't forget to join me in the live class, and I will give the example and we will discuss about the in the same chapter, the chapter title which we have. Tell me what is the chapter title? The chapter title is unit and measurement, yes or not? So in that we will discuss tomorrow application of dimension. First topic we will discuss and significant figures, rules for finding significant figures. Then next, significant figures in a algebraic operation, in addition or subtraction. Next, in a multiplication or division. Then rounding off. Then rules for rounding off a measurement. Then next, error we will discuss. Then absolute error. Then means absolute error and relative error or fractional error. Then percentage error. Then combination of error and error in addition or subtraction. Then error in a multiplication or division. These are the subtitle of the subtopic of the combination of the error. So in the combination of the error we will discuss error in addition or subtraction, error in a multiplication or division, error in a raised to a power. These up to this we will discuss tomorrow. So thank you joining my YouTube channel, and please keep watching, keep learning, keep sharing, keep subscribing. Thank you to giving, you have given your best time, you have given your precious time to listen me and learn something. Thank you. We will meet tomorrow in the live session. Have a nice day. Bye bye. Bye bye everybody.